Hi, we're just going to do a quick walkthrough of the Data Attacks Service Manager solution and talk through some of the capabilities and use cases. So if we take a look at the main dashboard after login, you can see we're presented with a table. That table represents your actual data attack surface. This is dynamically created roughly on the hour and computes an AI prediction based on permissions, copies of data, open ports, user behavior. PII. So yes, this product does classification, and you can see here the PII score is 10. That's the highest level it can be. It also integrates with your vulnerability scanner. Here we're showing Qualys, where we're pulling in a list of the CVEs, the average score for the host that this particular user is using, the most recent scan date, so it tells you if it's stale or not. We track this every 7 days. If the report gets stale, it will increase the risk of that machine. And this is the data risk score. This is the Superna computed exposure risk of that user and that computer based on a number of factors. So here we only have the two hosts, but let's walk through our dynamic policy enforcement. So we go to the enforcement policy tab, and we've got two rows, which I'll talk through here. We have the ability to build autonomous protection policies. So a policy, we'd give it a name, uh, call this financial data, some description, and source. So the source is like a firewall. I decide which machines or networks. So for example, you know, 0/24, so 254 hosts. If any server on this subnet touches IFS data financial, and the average risk score on the machine is, let's say it's medium to high or above, then this will raise an alert anytime any IO from this environment touches this data and the risk of that machine is medium high. This sends a webhook. That webhook can go and create tickets in ServiceNow, could go into your SIM, could use any of our integrations. There's another checkbox, data containment remediation. If I want to block access to that data, all I have to do is click that, create this policy, and I now have a real-time inspection process that's validating that the host and the user risk is below my target for that specific path or anything below it. And it will take action autonomously. So let's take a look at what that looks like when that happens. So these two hosts are in a locked out state. We're blocking any user access from this machine and this machine. The policy that was activated was this one, and the risk is medium. That's a pre-existing policy. This would send an alert, a different type of alert that can be integrated into, say, ServiceNow and say autonomous data protection policy is activated. This is the list. This is the user machine. This is the IP address. This is the name of the policy that they violated. And this is the reason why they were blocked. Imagine it was related to vulnerability scanning being either stale or vulnerabilities that exist on the machine. What can happen is you can patch the machine. Um, the data from the patched machine, the scan, a new scan, would be picked up dynamically, recompute the risk score. If the risk score drops below the target of the policy, we will autonomously unlock that machine. No actions required in this product, fully automated. If I don't turn on the autonomous lockout, which is fine, you just don't check the checkbox, then we will alert only. But in this instance, we've locked out these two machines. I can simply select one or more and click unlock and forcibly remove the lockout on those machines. This ensures that high risk data and high risk hosts don't interact. Let's protect the attack surface, shrink the attack surface through dynamic policy enforcement. So we're now going to move over to data classification. Data classification is a risk factor that we incorporate into decision making. Uh, Here we see a list of users and we see they have a PI max score of 10. The high score is 10. This means this user is interacting with PII data. In this case, it's credit card and email addresses. It tells you right here what types of things they're doing. It means they created or modified data with credit cards or emails within them within the last 7 days. That's important. We can change this filter and look at my PI risks at various times, 7 days, 14 days, 30 days, and so on. So the next question is obviously, where are they doing this? Well, now we're looking at the share view. So here's the name of the shares um, that are being accessed that have credit card and email address information within them. And I can now map out the individual users. This could be a long list of users or computers that are being used to interact with PII data. So now I understand the user computer mapping to PII data. That's what you need in order to measure risk and apply compensating controls. And so we give you the dynamic ability to track this at the share, the user, and the computer level. So I could, for instance, increase this out to 30 days and hit apply. And I could get a very different view of this. And of course, the quick and easy button, which is download to a CSV. We'll be adding more capabilities, including data overexposure to this interface. So we'll actually tell you at the share level if the usage of the shares is equal to the permission. So let's use an example where 100 users have access, but only 2 users access the data. That's an overexposure ratio of 50 to 1. You want to be at 1 to 1. We'll scorecard your shares, your cluster. We'll break it down by user, by share, by computer. So this will give you the ability to reduce that attack surface even further. Thanks for watching.